Hello guys and welcome. Like I said, we are going to be doing many lectures on balancing chemical equations. Today we're going to go over the law of conservation of math. This is something that we've already learned before. We talked about it on Friday, so this isn't new information. Then you're going to be doing some guided practice, all of which is due today. So we're going to do a little bit of lecture and then you're going to go ahead and do some guided practice by yourselves. Some individual practice. So remember, the substances in the beginning, or the law of conservation of mass, state, oh no, sorry, that's not what this says. The substances, I got ahead of myself. The substances in the beginning of a reaction, the ones that are reacting, are called the reactants. Not new information. We said the stuff on the left-hand side of the arrow, we call that our reactants. The substances at the end of the reaction or after the arrow on the right side, what is being produced, we call the products. The arrow sign in the middle reads yield, which we have talked about ever since we discussed photosynthesis. Your arrow means yield, which is a big fancy word for saying creates. So that tells us that when we read a chemical equation, our reactants yield or create our products. Like right here. So what do you think is covered by my light blue box or my Na and my Cl? What are those? What do we call them? Reactants. And remember that arrow means yield or create our products on the other side. So we take sodium ion or sodium elements or atoms plus chlorine atoms, bond them together, and we get sodium chloride or salt. The law of conservation of mass says that matter cannot be created or destroyed. We talked about that on Friday. That means that the mass of the reactants must equal the mass of the products. So whatever I have on my reactant side has to be on my product side. That's why we said we have to balance our chemical equations. Remember, our mass of our reactants must equal the mass of our products. When balancing the equations below, focus only on the mass of the reactants and products. We haven't talked about this yet, so this will be new to us, but don't worry, it's just simple subtraction. So if I have 30 grams of sodium and 40 grams of chlorine, how many grams of sodium chloride do I have? I would figure that out by adding 30 plus 40, which we know equals 70. So I have 70 grams of sodium chloride total because the law of conservation of mass tells us that the mass on the reactant side must equal the mass on the product side. Now if we do our blue one, our second one here, how many grams of calcium do we have? And how many grams of, we know we have 35 grams of oxygen. So question, how many grams of calcium plus our 35 grams of oxygen equals 150 grams? We know that we have 35, so our 150 total is what this needs to be. We know that 35 grams of those comes from oxygen, so we must take 150 minus 35, which equals, which equals 115. So we should have 115 grams of calcium. 115 plus 35 equals our 150 grams of calcium oxygen molecule. Now if we look at the third one, or the gray one, we have 10 grams of sodium plus 100 grams of magnesium fluoride equals 50 grams of sodium fluoride plus how many grams of magnesium? So we know we have 10 plus 100 equals 110. And then we know that of that 110, because what is on the reactant side must equal the product side, we know that 50 grams of our product comes from the sodium fluoride. So we go out to take 110 minus 50, which equals 60. So we should have 60 grams of magnesium left. If we do the teal one, we have an unknown amount of grams of sodium plus 12 grams of magnesium fluoride again. And we know that 20 grams are going to be of our sodium fluoride, and we'll have 82 grams of magnesium. So we have to figure out the total mass on the product side, which equals 102. And then we know that on our reactant side, 12 grams comes from magnesium fluoride, so we must take 102 minus 12, and that leaves us with 90. So we should have 90 grams of sodium. And then for our final one, we have 50 grams of nitrogen gas plus 15 grams of hydrogen gas equals an unknown amount of grams of nitrogen, hydrogen bonded together in a molecule. So because our reactants mass must equal our product's mass, that means we add up the mass of the reactants, which is 65. And that should equal what's on the other side. So we have 65 grams of nitrogen hydrogen gas or ammonium. Moving on. So what are the reactants in that product or in that reaction if we go back? The reactants are the nitrogen gas and the hydrogen gas. And the products are ammonium right here. So remember, our reactants are on the left side of the arrow and our products are on the right side. Are each of these elements or compounds? So what do you think? Are these elements or are they compounds? Remember, an element is just one single thing not bonded. So we know that the reactants are considered elements, or molecules would be a better word for them, because they just contain one kind of atom. Ooh, our things are out of order. So is the product an element or a compound? We know it's a compound because we've got two different things bonded together. These are considered, the nitrogen gas and the hydrogen gas are considered elements, or more specifically molecules, because they're made up of one type of atom. Our product, on the other hand, ammonium, is made up of two types of atom, nitrogen and hydrogen, so we know that they are a compound because they are made up of two different types of atoms, nitrogen and hydrogen. So this is the end of your introduction. So from this point forward, you're going to go ahead and do the guided practice by yourself. It looks like this, so you should have finished this whole part. Now you're going to do the independent practice, not guided practice, all by yourself. When you're done, you're going to turn the entire completed sheet in. If you have any questions, please email me. Have a great day, guys.